Hello, my name is Josh Obert, and I'm a GIS analyst with the ACPF National Hub. In this video, we're going to discuss the Runoff Risk Assessment Tool. This is the fourth and final tool in the Field Characterization section of the ACPF Toolbox. The Runoff Risk Assessment Tool ranks fields based on their susceptibility to runoff. The Runoff Risk Assessment uses two variables to classify agricultural fields by their risk to direct surface runoff. The first variable is slope steepness, which we'll get by using the by-field slope statistics tool we ran earlier. And the second variable is the stream proximity, which is actually converted to a sediment delivery ratio. This value is the output from the previous tool, D8 distance to stream. The fields are given a rank of either high, medium, or low based on these variables. In ArcGIS Pro, we will open the catalog window in the right side of the screen if it isn't already open by clicking the catalog tab. Expand our ACPF toolbox, expand field characterization, and double-click Runoff Risk Assessment. This tool has multiple inputs. The first is the field boundary feature class. Our second input, the slope table, is needed because it contains the slope steepness for each field. The third input is the distance to stream raster, which we just developed and is used to develop the sediment delivery ratio, which is essentially the stream proximity variable. We then have different break values that we can set for both of these variables. These variables are optional, so you don't have to include them. We have the high and medium third quartile slope thresholds, and then high and medium thresholds for the sediment delivery. If you do not include these, they will be automatically split into a 20-40-40% breakdown. Let's discuss this further. The first variable to the runoff risk assessment is steepness. This is going to use the 75th percentile slope for each field that comes from the slope table. The two images below show the difference between automatically generated thresholds of slope and the user-defined thresholds. Although it's kind of difficult to convert sediment delivery ratio to numbers that actually mean something to the user, people generally understand slope. And you may know for your watershed that slopes 10% or higher are much more at risk compared to other ones. For this watershed, if we let the tool automatically break it down, slopes of just about 15% or greater are considered to be at high risk, where in reality, that's probably not the case. So for the statements variable, it may make more sense to actually define what is your high and medium threshold value. The second variable of the runoff risk assessment is stream proximity. Values from the distance to stream raster will be converted to a sediment delivery ratio. The sediment delivery ratio has a range of 0.17 to 1. Distances less than 10 feet are converted to a sediment delivery ratio of 1, indicating that they're very close to the stream, and distances that are 5,000 feet or greater away are converted to a delivery ratio of 0.17. If you were to set those breaks, you would definitely want to set it in between this range. If you set the high threshold value, it means a high sediment delivery ratio would be between this value and 1. When you set the medium value, it is that medium to the high value, and then anything below that will be 0.17 to that medium value. And that will be considered the low sediment delivery ratio. Once again, you can leave these blank and they will be automatically generated into a 20-40-40 split. Back in ArcGIS Pro, let's get an idea of the slope characteristics of each field within this watershed. Let's open the slope table by right-clicking on it in the table of contents and clicking Open. We know the tool uses the 75th percentile slope, so this will be the field that we want to focus on. Let's right-click on this field header and choose Explore Statistics. These statistics show that the mean by field 75th percentile slope is 14.25. The minimum is 1.62, and the maximum is a whopping 50.45%. We can right-click on the chart and click Open Histogram. This will show our distribution of the field's 75th percentile slope values. It appears that the majority are going to be in this 10 to 12 range. This gives us an idea of what a steep field may look like in this watershed. Let's close all these down. We will enter our inputs into the tool. For the first input, we will choose our field boundary feature class. This will automatically populate our second input, the slope table, from our geodatabase, and our third input of distance to stream raster. We will leave the thresholds blank to let the tool automatically develop those. The one output we're going to get is the runoff risk table, which has also been automatically populated. Click Run to run this tool. The Runoff Risk Assessment Tool has just finished running, and we can see that the result, a runoff risk table, has been added to our map. We will join this table to our field boundary feature class. To perform the join, right-click on the field boundary feature class, go to Joins and Relates, and click Add Join to open the Add Join window. Our field boundary feature class will auto-populate as the input table, since that is the one we said Add Join on. The runoff risk table does not show as the join table, so we will choose it from the dropdown. For input field, we will choose our field boundary ID. Since the runoff risk table has the same field, ArcGIS Pro recognizes that the field exists and will set that as the join field. Let's hit OK at the bottom of the Add Join window. Select our field boundaries in the table of contents on the left and click the Symbology tab in the right panel to open the Symbology window. From the drop-down, under Primary Symbology, click Unique Values. We will be visualizing on the Runoff Risk Rank field, so we will select that field from the field drop-down. This will be the last field listed. For color scheme, we will select Red, Blue 5 classes. Make sure Show Names and Show All are selected. The values for runoff risk run from very high to low. This allows us to visualize which fields are more at risk than others. Initially, looking around the watersheds, the fields closest to the stream tend to be higher for runoff risk. If we open the attribute table by right-clicking on our field boundary feature class in the table of contents and clicking Attribute Table, we can slide over to look at the values that come from the runoff risk table. We get the individual ranks for the slope and sediment delivery ratio based on either the generated or manual thresholds. All these fields that contain the words null are non-agricultural. We also get a distance to stream field, an adjusted distance to stream field, and the values for sediment delivery ratio and slope. Looking at the slope and sediment delivery ratio values may give you an idea for thresholds in case you wanted to rerun this tool with manual values. To recap, we ran the Runoff Risk Assessment Tool and discussed how we can determine what thresholds to use as inputs. In the next video, we will begin the next section of the ACPF Toolbox, Precision Conservation Practice Siting, by running the Depression Identification Tool.